Okay, so what we were looking at last time was some ways to try to measure the degree of imbalance that we have. And one of the things that we saw was our within season variation, right? So that we would have, for example, this theta WT, and then we said, okay, the summation here, I equals 1 to n, WPCT IT minus 500 squared all over n, and then in essence we took the square root of that. But one of the things that we saw was that you can have some problems here with the length of the seasons, right? And we saw that with the tossing of the coin, where if we had like 10 coin tosses, we had, I think, 7 heads and 3 tails one time, and the other time was 6 and 4 or something like that. As opposed to 100, then we had like 107, or 200, I think is what we had. We had 107 heads and 93 tails or something like that, right? So in essence, what we want to do is we kind of want to adjust this guy for the length of season, right? Because we have all the way from 16 games in the NFL all the way up to 162 games in Major League Baseball. So what we want is we kind of want to have a correction for this. So we're going to call this guy, say, theta I is equal to 0.5 square root of g here, right? Where in essence g is our number of games. And each team, in essence, kind of being here, say 50%, right? So we have this idealized standard deviation. So for our purposes here, so we, once again, like I said, we've got 16 games in the NFL. Well, that gives us an idealized standard deviation, 0.5 divided by square root of 16, right? That's 0.125, right? We've got 82 games in the NBA. .5 square root of 82. All right, so 0.055. We've got 80 games in the National Hockey League. So this guy gives us theta I 0.5 square root 80. All right, well, he's going to not be exactly equal to 0.055, but pretty darn close. 162 games in Major League Baseball. Okay, so that means we have this idealized standard deviation of winning percent, 0.5 square root 162, give us 0.039, right? So we can kind of use these guys to say, okay, how are we, what is our number in relationship to these numbers? Because that's what we're really interested in. So we can take the ratio of this right, with kind of our actual over our idealized. And we could say, oh, okay, so this guy in the NBA in the 04-05 season was 0.152. Okay. So our theta W here, we've got our 0.152. And we want it to be at like 0.056. Gives us basically, like, say, around a ratio here of like 2.71. So we can use this to say, okay, if here's our idealized amount, you know, how far away are we from it actually? So for example, here our 2005 actual, so here's Major League Baseball, here's our NFL, here's our NBA, here's our NHL. This guy was .066, this guy was .208, this guy was .152, this guy was .099. And we know what our idealized amount is, right? That's our .039 for Major League Baseball. It's our .125 here. It's our NBA's .056, NHL .055, right? So here's our ideal. So when we look at our ratio here, 1.69, 1.66, 2.71, 1.76. Because remember, what did we want this guy to be? Right? Remember, we said the larger this number, the larger the variance. But if you look at this guy, if you look just at these numbers, who's worse off? Who's got more competitive imbalance? Mm-hmm. But their numbers should be higher. They've only got 16 games. You only have to get it right 16 times. They got to get it right 162 times. So when you look at the ratio, what do we see?
MLB is more competitively imbalanced than what the NFL should be.
Well, is there a big difference between 1.69 and 1.66? I don't think so. You look at these guys from this, right? Remember, we said the larger this number, the more competitive imbalance they have. And then you say, oh, okay, here's Major League Baseball, 0.066. Here's the NFL, 0.208. You just look at this guy, what stands out at you? I mean, this guy right here compared to there is what? 3 times as large, right? More than that, almost 4. So it would appear from just this number right here, hey, look at this. Oh my goodness. The NFL is 4 times as much competitive imbalance as Major League Baseball. But their numbers should be higher. And if you look at the ratio, these guys are actually pretty close to each other. They're actually not that far away. If you look at these guys, what do you see? What's this guy tell you, looking at just those 2 numbers?
More variance in the NBA.
Yeah. The NFL has got a lot more variance. They're more competitively imbalanced than the NBA. But when we look at these guys, what do we see?
The NBA had abnormally large variance.
Yeah. I mean, these guys should be here, and the .056, they're 3 times as competitively imbalanced as what they should be. And in fact, here, the NBA has the highest amount of competitive imbalance. In a way, I mean, that kind of really shouldn't be surprising, right? I mean, how many people are on the court at one time on the team? 5. So if one of those persons is bad, 20% of your team sucks, right? In football, if one of the people is bad, 0.9%, 9% of your team sucks. In Major League Baseball, if you got one guy that's bad, 11% of your team sucks, right? So you have in here the ability for kind of a star in the NBA can make a much larger impact than a star in the NFL is what I'm saying. That's basically what I'm trying to say. And they can have a much larger impact. There's just more opportunities for them to screw up or for them to do exceedingly well. So we can also look at between season variation, right? Because we know that these things can change season to season. So we can alter this guy so that we can know how he's changing over time. So basically we're wanting to know how do teams increase or decrease over time. So same thing, here's our theta IT. We get our summation, I equals 1 to t, WPCTI minus WPCT bar squared, all over t, right? Where here t is our number of seasons. This is our winning percent. Over t seasons. So the larger this guy becomes, the more team fortunes change. So we saw that with the within season variation, if we had that guy being really, really large, there was a big differential. One team's at 0.8, one team's at 0.2. This guy, though, what do you want him to be, large or small? If for a team this guy is equal to 0, what does that mean? They're the same year in, year out. They're always fifth place in the division. 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 If a guy is 0 for all teams, what does that mean? What does that mean if it's 0 for all teams?
Everybody wins the same amount of games?
Nope.
I mean, like the first place team is always the first place team, the fifth place team is the fifth place team.
Everybody is in the exact same place every single time. You can already know who's going to be the head of the Atlantic Division in the NBA, who's going to be at the bottom of the Atlantic Division. You already know who's going to be ahead in the Central Division in the National League. You already know who's going to be winner in the Eastern for the NFC. I mean, all that stuff. It's all done. Doesn't even matter. It's all squared away. You already know exactly where everyone is going to be. So, like we said, all right, with this within season 1, this guy, when this guy was large, that was kind of bad, right? But this guy being large, that's good. That means people are changing places a lot. Problem, of course, with this guy is, well, what standard do you use? How much change should you have? I don't know. Right? I mean, what's the idealized number for this guy? We kind of have a sense of what the idealized number for this guy is. Well, what's the idealized number for this guy? I don't know. Yes?
So for the team that equals 0, does that mean that they're coming in last every time? Or
Nope.
that
They're
placing
placing the same every time. Yes.
Does that just say their final record will be the same as the year before?
It's just their
Does that
place.
say that what teams they lose to, what teams they beat will be
It's their winning percentage.
just their winning percentage?
So if they were 303 this year, their winning percentage over these 2 seasons. Always going to be 3. If it's equal to 0, this number right here has to be equal to this guy every single time. And it doesn't matter what the number is, because it's this team right here is 303, and this team over here is 697. So the outcome of individual games might be uncertain. But if you know that these teams are always going to go to the championship game, these teams are always going to lose, it could get boring. We also have some other indices to measure competitive imbalance. We've got the Herfindahl-Hirschman Index. This is the HHI. This guy is used in I/O, an industrial organization. He's used to determine the concentration. So this guy is the summation, basically, of market share squared. This is the HHI, right? So let's illustrate what we mean by this, right? Because this guy is actually, like we said, it's actually used a lot in I/O. So if you're looking at market share, if you've got 4 different companies, and they each have an equal market share, they each have 25%, right? So in essence, you've got 25 squared plus 25 squared plus 25 squared plus 25 squared. And this is just some number, whatever this number is, right? And I didn't bring my calculator in with me. Oh, look at this. So for this guy, 625. We would have a Herfindahl-Hirschman index of 2,500, right? So you've heard when 2 companies want to merge, right? And the government looks at it and says, this is going to hurt competition or it's not going to hurt competition, right? This is one of the things that they use to look at that. So if you have, say, one company, they have 100% market share, right? Well, 100 squared is 10,000. So this guy has a range from 10,000, right, all the way down to essentially 0. And you can look at this in a lot of different ways. Right? You basically want to add up all of this market share for all these different companies. But you can see if you had, say, 100 companies, and they each had 1% market share, well, you've got 1 squared plus 1 squared plus 1 squared plus 1 squared plus 1 squared, blah, 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 blah. Add all that up, right? So if you have these 100 companies that each have 1% market share, what would this guy's Herfindahl-Hirschman index be? Exactly. Right? So he's going to range all the way from 10,000. I mean, you can go to 0, I guess, and get really, really close to 0. Right? Because you could have, if you had 1,000 companies, and they each had equal market share, it's going to be 0.1%, right? But 0.1% squared is 0.01, right? And you add up 10,000 of those, or 1,000 of those times 1, 1, 2, 3. Right, here we get a value of 10, right? And on and on and on down the line, right? So the larger this guy becomes, the more concentrated the industry is. And it doesn't have to be that they all have equal share. You could have 4 companies here. One has 70%, one's got 10%, one's got 10%, one's got 10%. It could be anything. All right, so you could have 70 times 70 is 4,900 plus 100 plus 100 plus 100, 5,200. Same 4 companies. Here, you've got a HHI of 2,500. Here, you've got an HHI of 5,200. Simply because one of the companies has a whole lot more market share, right? Or you could have 4 companies, one has 90, the other 3 have 3.33%. It can be anything. So we can use this guy that's used in I/O to measure market concentration. Well, we can use it in sports to measure essentially competitive balance or competitive concentration. So let's look at this, and I mean, you can look at it in lots of different ways, but let's look at it in a simple way. Let's look at it as the number of times a team gets first. Okay? So let's consider a league with 5 teams. Got a 5-team league. And here in the 1960s, each team finished first twice. In the 1970s, 2 teams finished first 5 times. Right? They traded places. And in the 1980s, 1 team finished first 10 times. Okay. So what we want is we want the HHI for these guys, as far as these leagues during these 3 different decades. All right. Okay, finished, how many times did team 1 finish first? 2, square that. How many times did team B finish first? 2, square that. Team C, 2, square that. Team D, 2, square that. Team E, 2, square that. All right, we're going to get a value of 2 for this guy. Here we got 2 teams doing it. Well, Team A finished twice 5 times. Team B finished twice 5 times. Team C, D, and E finished first 0 times. Right? So 25 and 25. This guy is equal to 5. Right? Same thing here. So we see here, if we look at this in terms of the HHI, the number of wins, the 1960s is clearly more competitively balanced than you have in the 1980s. I mean, you wouldn't even have to figure out the number to know that, right? each team in a 5-team league finishing twice first means that's a pretty even distribution of wins. 1970s is a little bit worse. 1980s is the worst, right? One team finishes first 10 times. Every single time you know the Cowboys are winning. What's the point of watching? However, what's the ideal number? I don't know. You know that as this guy is increasing, you're having less competitive balance. But you can't really know exactly what that number actually should be. It's not exactly clear. Do you have a question?
Yeah. Why do we divide by 10?
Because you've got 10 years in that season. Or in that decade, I mean. We can also have championship imbalance. There's another way to measure it. If there is lots of imbalance in the postseason, we can use that as a proxy for imbalance in the season. If it's the same teams going into postseason every single year, it's the same teams winning, then that's a pretty good sign that we've got imbalance in the regular season, right? So if we have a league that has 10 teams, we should be getting, on average, each one of those teams, if we have perfect balance, in any given decade, what should each of those teams be doing? What should we see happening?
Each team wins once.
Exactly. Right. If we have 10 competitively balanced teams, we should see each team wins once a decade. Right? It's like we were talking about with the Yankees. 25% chance in any given year. Take all of the World Series that have ever existed. They're in 25% of them. Or no, they're in a third, they win 25%. There's a whole lot more than 4 teams. So if we have, what do we have in baseball? 32 teams, is that right?
30.
Is it 30? So if we have 30 in our Major League Baseball, 32 is NFL. We should see one team winning about every 30 years. How many teams in Major League Baseball have never won the World Series? Tampa Bay? Nope. Nationals? There's a whole bunch, basically, right? It's easier to count the teams that have won than it is to count the teams that have not won. Similar things here. All right. Once again, we use it as a proxy. I mean, this is one of the reasons that you have the wild card, right? The whole idea behind wild cards, basically it gives more sport. But it's trying to say, here's these teams, Team 1, Team 2, Team 3, Team 4, Team 5, Team 6, 7, 8, 9, 10, 11, 12, 13. Well, gee, if we just go on wins, right, maybe it's just these guys that are playing. We want to find a way to bring in more balance. We want to try to make the sport more exciting so that it's not basically, you know, a foregone conclusion that it's always going to be these guys over here, right? I mean, if it's always just based upon winning percentages at the end of the season, those are the only teams that are going to play. It's going to be basically the same 10, 12 teams, whatever it is. Let's have a wild card. We'll throw some numbers. We'll throw some other teams in there and at least gives a chance, right? And that's the whole point of it. Okay, I can see by the clock we got 5 minutes, which is not enough time to start the next topic, which is, if we know that we've got competitive imbalance, what are some remedies to get rid of competitive imbalance? What are some things that we can do? Okay. And to give you a hint of some of the things that to come, we've got things like the draft. We've got things like salary caps, luxury taxes, revenue sharing. Things that we can do to try to change this competitive imbalance, make sports a little bit more exciting, right? But I'd have to start all over again with the topic on Monday anyway, so might as well just let you guys out a little early today. So, all right, I'll see you guys on Monday.